This is related to the heat of neutralization. The rise in temperature on mixing of 200 milliliters of 0.05 molar NaOH and 200 ml of 0.05 molar HCl is T1. Instead of 0.05, if we use 0.1 molar solutions of both the substances in the same volumes, now we need to find out the rise in temperature is given as T2, and now we need to relate between T1 and T2. We know the basic concept that the rise in temperature is directly proportional to the amount of heat released in the process of neutralization, isn't it? So greater the amount of heat released, more is the rise in temperature. So now here we need to find out how much heat is released in both the cases. Then we can definitely relate between the rise in temperature. So when we take the first case, when we are taking 0.05 molar solution of sodium hydroxide as well as 0.05 molar solution of hydrochloric acid. Let us take the amount of heat released as equal to Q. Now here I am not involving volume because in both the cases we are using the same volume of both the acid and bases. In the second case we are using 0.1 molar solution of the acid and base. So definitely when compared to the previous one, the amount of heat released is more and exactly is double that of the original one, isn't it? Because here the concentration is 0.05 molar, and where in the second case the concentration is 2 into 0.05 molar. So definitely the amount of heat released is double that of the original one. It is equal to 2Q. So when Q is the amount of heat released, the rise in temperature is T, and that is the T1. And when the amount of heat released is 2Q, the rise in temperature definitely it becomes 2T, and that is nothing but T2, isn't it? So now what is T2 value? T2 value is double that of T1, or T1 is nothing but equal to half of that T2. And see which of the options possess either of these two relation. It is there in option C. So our answer is option C.